Hi, I am Lopamudra Sen. Welcome back to my channel Electronic Science Tutorial. I have already discussed some important topics of digital electronics in my channel. From previous class, I will start some other important topics of digital electronics like canonical expression in my channel. Those who are not subscribe my channel but follow my channel, please do like, share and subscribe my channel. It will encourage me. So please like, share and subscribe my channel. सब्सक्राइब की बेल आइकन को प्रेस करके रखिए ताकि जब भी मैं कोई नई वीडियो लेकर आऊँ आपको पता चले. So let's get started. In today's class we talk about the canonical SOP functions. How can we represent from a truth table the canonical SOP function? Or from the decimal notation, how can we represent the canonical SOP functions? Okay, we talk about those topics in this slide. In this slide, we talk about the canonical SOP expression. How from the decimal notation, we can easily convert or we can easily get a canonical SOP expression. We talk about this topic. Okay. Our first example is f, which is a function of a comma b comma c, which is equal to summation m small m, which means min term, function of 0, 3, 5, 7. We already know that is sum of product is represented by plus term, sum of product. So it is represented by plus term. So what is the function? That is m0 plus m3 plus m5 plus m7. Right? Next, in SOP expression, 0 is represented by a complemented variable and 1 is represented by a single variable. So m0 means 0, 0, 0. Decimal notation is 0, but its binary representation is 0, 0, 0. So how it is defined? That is a bar plus b bar plus c bar plus, next is 3. Decimal number is 3. What is the binary representation? That is 0, 1, 1. So 0 is represented by a bar, 1 is represented by b, c is represented by 1. Okay. Plus m5. So decimal number 5 is represented in binary form, that is 1, 0, 1. 1 is represented by a, 0 is represented by b bar and 1 is represented by c. Plus m7. Decimal number 7 is represented in binary form, that is 1, 1, 1. So here we write a, b, c. So this is the expression which we get from this decimal notation. That is 0 is represented by a bar, b bar, c bar plus 3 is represented by a bar, b, c plus 5 is represented by a, b bar, c plus 7 is represented by a, b, c. So this is the canonical SOP expression. From this decimal notation we can define this expression, right? Next example is f, which is the function of a, b, c, which is equal to summation m, which is a function of 1, 2, 4 and 6. So how can we represent this? That is m1 plus m2 plus m4 plus m6. Next, decimal number 1 is represented in binary form 0, 0, 1. So here we write a bar for 0, b bar for 0 and c for 1. Next term is 2, which is the binary form of 0, 1, 0. So 0 is represented by a bar, 1 is represented by b and again 0 is represented by c bar. Plus next term is 4. So 4 is represented in binary form 1, 0, 0. So 1 is represented by A, 0 is represented by B bars, and again 0 is represented by C bar, plus next term is M6, which is represented by 110. So 1 is represented by A, B is represented by 1, and C is represented by 0 is represented by C bar. So what is the expression? That is A bar B bar C plus A bar B C bar plus A B bar C bar plus A B C bar, which is the function of this decimal notation. So in this way we can easily, from a decimal notation, we can easily convert a canonical SOP expression. Okay. In this slide we talk about the SOP expression which we get from a truth table. So here we consider the following truth table of a 3 variable switching function and find the canonical SOP expression for the function. Let's talk about this truth table. Okay, let us see the truth table. That is, this is the truth table. This is the truth table. A, B, C are 3 variables. F is the function of A, B, C, which is the output. Here we write the 8th possible combination of 3 variables, that is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and the last combination is 1, 1, 1. For 0, 0, 0, output is 0. For 1, output is 1. For 2, output is also 1. For 3, output is also 1. For 4, output is 0. For 5, output is 0. For 6, output is 1. And for 7, output is 0. So how can we express a canonical SOP expression from this truth table? First, 1 is getting here, that is 1. For which value? That is A is 0, B is 0, C is 1. So how can we define this term? That is A bar, B bar, C plus. Next one is getting here. What is the value of this one value? That is A is 0, B is 1, C is 0. So A is 0 means it is represented by bar. B is 1 means it is represented by a single variable B, A bar B, and C is also 0. So again it is represented by C bar. So A bar B C bar. Next one is getting here, that is for 0 1 1 combination. 0 1 1 combination means 0 is represented by A, so it is A bar B C plus the fourth one is getting here, that is for the combination 1 1 0. So 1 means A is represented by 1, B is represented by 1, and C is represented by 0. So this is the expression, that is A B C bar. So what is the function? That is A bar B bar C plus A bar B C bar plus A bar B C plus A B C bar. So this is the function of this. This is the canonical SOP expression for this truth table, where we consider only one term, that is the mean term, right? So here we can write in this way, that is M1 plus M2 plus M3 plus M6. 1, 2, 3, 6. Okay. So that is the summation M summation M function of 1, 2, 3, 6. So this is the decimal notation of this expression. So in this process we can easily, from a truth table, we can easily convert, or we can easily define a canonical SOP expression for the function, right? So here we end today's session. Thank you. If you like my video, then please like, share and subscribe my channel. फिर मिलते हैं एक नई वीडियो के साथ. Thank you.